Have a good day, students. So, this grade 11 revision, grade 10 lessons we are discussing today. So, I have given you the tutorial. So, I think you have done the tutorial. So, this time to check the answers. Now, this is the lesson. These are the lessons you are getting in this tutorial. Newton's laws, resultant forces, equilibrium of forces, friction, and turning effects. So, there are 25 MCQs. First, I'm going to discuss about that. So in here, revision questions, underline the correct answer. So start from the first question now. We are starting from the first question. In this question, they are telling what is the fundamental unit of force. You already know the SI unit of force. SI unit of force is newtons, but here we are now learning about the fundamental unit. To get the fundamental unit of any parameter or any measurement, we need to get the equation, how you get the knowledge about it. So force equals mass into acceleration. So I substitute the units of these stuff, mass and acceleration, kilogram and meters per second, square second. So kilogram meters per square second is the fundamental unit of force. So here you can see two answers, this one and this one is wrong. There are two answers, kilogram meters per square second and kilogram meters per square second here. What is the difference? You can see the K letter is different. Actually kilogram is written in here simple K, simple G, so the answer is third one. Right. We go to the next question. Which of the following example is not related to Newton's first law? Newton's first law, we are recalling that thing first. We are recalling Newton's first law like this. In the Newton's first law, it says that the object is remaining stationary or move at a constant velocity when there is no unbalanced force is applied. So if I say the law correctly, unless an unbalanced force is applied, the object will remain at rest or move at a constant velocity. Let's see now, are these answers matching with that definition. A carom piece will start to move when the disk hit it. That means you know that a resting disk is moving now due to the unbalanced force. So the first one is related to Newton's first law. Second one, a passenger will drag forward when brakes are applied. When brakes are applied, the passenger will receive an unbalanced force, so the object or the passenger is start to drag forward. So this is also related to Newton's first law. A football will continue to roll for the certain distance. Why it is going just for a certain distance? Because of the friction, the object is receiving unbalanced force and cause deceleration in the material. So deceleration causes the object to confirm that Newton's first law is applied. A boat will move forward when pushed by the pedals. When you push, that means you are giving an action to move the boat forward. So action and reaction thing is related to Newton's third law. So this is not explaining Newton's first law. So the answer is question number 2. Answer is 4. Now we are going to question number 3. We are going to learn about that part. In question number 3, a trolley of mass 5 kilogram receives a force of 200 newtons. What will be the acceleration of the trolley? The force is given. So this is the way we do these type of MCQs. We first mark what are the data they are giving, then you can take an idea what you are going to do. Otherwise you can't understand what's the thing we are going to do. So if it is F, force is there and mass is m, ask in the acceleration. See, if you write this, you can understand what is the relationship you are going to make, because you studied that there's an equation called force equals mass into acceleration, F equals ma. Now you are going to find the acceleration. So I subject acceleration in this equation. If you subject acceleration, you are getting force over mass. I cross multiply both sides. You can see it becomes, if you divide this side by m as well as this side by m, you get this thing cancel out, and acceleration equal force over mass. So force is 200 newtons. And what is the mass? Mass is 5 kilogram. See here, you can cut this to this and you get the answer 40 meters per square second as the acceleration. The answer is, now going to question number 4. A van of mass 100 kilogram was moving with at a velocity of 20 meters per second, accelerated up to 40 meters per second. So you can see it was moving at a certain velocity. Now after 5 seconds they are mentioning that this object is accelerated up to 40. So in here also you are going to mark these things, right? Mass 20 to 40. That means this is the initial velocity and this is the final velocity. And this is the time. Seconds. Due to the extra force exerted by the engine, you can see the extra force is exerted. Extra force means there's an unbalanced force. This is the force then. What will be the extra force exerted by the engine? So to find the force, what they are giving you, see, you just can't apply to this equation MA. You're going to find A first because A is not given here directly, but indirectly you know acceleration is equal to change of velocity. That means V minus U, change of velocity, final velocity minus initial velocity divided by time. Here you can see I substitute immediately 40 minus 20, time is 5. So you can see here 20 divided by 5 because 40 minus 20 is 20. 20 divided by 5, answer is 4 meters per square second. Then you substitute to here. Mass is 100 kilogram, 4 meters per square second. Answer you can see 400 newtons. Answer 3. Now we are shifting question number 5. A golf ball was knocked by a golf bat with an average force of 200 newtons. What will be the final acceleration of the golf ball if it's having a mass of 200 grams? Here there's a special thing to discuss. The SI unit of mass will be kilogram, but this is in grams, so make sure that you are not doing the careless mistake here. So force is given, you can see here, mass is given, asking the acceleration. So again you can see F equals ma. F equals ma. Here there's a special thing to convert this 200 grams into kilogram. You know that 1000 grams equals 1 kilogram. So you divide this 200 by 1000 into acceleration is how much? We don't know that, but we know the force. Force is 200 newtons. Here you can cut 2 zeros of this, you get 0.2. So I further solve this thing. Acceleration equals 200 divided by 0.2. You can see here when you mathematically substitute this thing here, solve this thing, you get 2000 divided by 2. You can cut this to this, you get 1000 meters per square second. That is the acceleration of the object. Here there's a small correction, it should be -2. The answer is third one. We go to the question number 6. Bullock cart of mass 100 kilogram was attached to the bull of mass 80 kilogram, and the cart was moving with a velocity of 5 meters per second. What will be the momentum of the cart? Now a different question. We discuss about F equals ma. Now about momentum. Momentum. You know that momentum means the mass into velocity product. Momentum equals mass into velocity. Right. You are just substituting. This is an easy answer. But remember, when you are substituting, you just can't substitute only the cart, because the bull has a mass of 80 kilogram and the cart has a mass of 100 kilogram. So remember, altogether the mass is added 180 kilogram into 5 meters per second. So easy case, 5 times 18, 990, you get 900 kilogram meters per second. Right, this is the answer. You can see the answer is third one here also. Question number 7 we are discussing. Question number 7, let's see what we are getting here in question number 7. Which of the following about the masses and the weight on the earth is correct? You know the difference between mass and weight. Weight is a force measured in newtons. Mass is the amount of matter measured in kilograms. So how to convert the mass into weight? You know that weight is equal to mass into gravitational acceleration of the planet. So from recalling this memory, you get this thing here. A balance can only be used to compare the weight, not masses. A balance, you know that in market you can see the balance, the pan balance. In the pan balance you can see you are measuring the masses, like measuring 1 kilogram by putting another mass to the other side. So this is the pan balance. You can see if you want to measure the mass, you are putting something here and put the required amount of 1 or 2 kilogram mass into this side and you balance it. Even you know that gravitational acceleration is occurring for both objects downwards in the same value. That means no matter you measure the weight or the mass, they can measure it because gravity is affecting the weight. So if it is same gravity, this factor is a constant here. That means you can see from the pan balance, you can measure the weight and the mass both together. So it says compare the weight, not the mass. This is wrong. Heavy objects always have more mass than lighter objects. It says about the earth, on the earth, inside the earth, everywhere we can say the gravitational acceleration is same. So if the mass is more, the object is becoming heavier, because gravity is a constant, only the mass is affecting the weight. So that is correct. Large objects always have more mass than small objects. This statement has a small error because the reason is large objects means not the what? Not the mass, because the density of different objects, for example, if this is the 1 kilogram of iron, if this is 1 kilogram of iron, to balance this amount you need actually this size of cotton wool with the same mass. This size of cotton wool will have 1 kilogram equivalent to 1 kilogram of iron. These two are different densities, but their sizes are, you can see, also different, but their masses are the same. So you can see large objects always have more mass. That is actually wrong. Mass is a force, but weight is not. No, the reverse way is the thing. Weight is a force, mass is the amount of matter. So the answer, you found it, 2 is the answer. Second one is the answer. Next. Some objects with mass 4 kg are resting on a table as the diagram given below. What is the magnitude of and direction of perpendicular reaction force exerted on the book by the table? Then you can see, you can draw this thing. Otherwise, you can't just get the idea and draw this. This is the table. This is the object like this. So always you know from the center of mass there's a force downward, that is the weight of the object. So weight means mass into gravity. The reaction is exerted by the surface upwards. The reaction is exerted, perpendicular reaction. So asking that some books of mass 4 kg. The mass of this thing is 4 kg. Magnitude and direction of perpendicular reaction, you know it is upwards. So there are two answers upwards. You can cut this one and this one. And what is the value? You know, you go to Newton's third law. If this is at rest, if this is resting, here it says, if this is resting, we say upward forces are equal to downward forces. Every action has equal and opposite reaction. So that means if the action we found, we can find the reaction equivalent, because mass is 4 kilogram and the gravitational acceleration is giving. So from that also you can get a clue that you're going to convert mass into gravitational into weight by using gravitational acceleration. You get 40 Newton this side, 40 Newton downward as the weight. So same amount will be upward. So the answer is third one. Right. We go to the next question. In this question, it's about forces. See the forces where they are acting. What will be the resultant force? Now another lesson. After learning about Newton's laws, now we are learning about resultant forces, or we call the equivalent forces of a force combination like this. So you can see resultant force is the net force acting on a point due to the direction vector addition of two or more forces. So here this vector is upward and this vector is downward. So when you are adding these two things, you can see upward, downward things are not added like this. If you say resultant force to the upward direction you have 2 Newton upwards plus you have 2 Newton downwards. See that? So can we able to add these two? No. The reason is these two things are occurring in the opposite direction. So you have to make this one of this into the same direction as the previous one. So I'll keep it the first term as 2 Newton similar to the upward direction. But now when we want to change this thing, you are going to put the minus sign because you are going to change the direction. These are vectors. So you get the here minus 2 plus 2. The answer is 0 Newton. So vertically you can see there's no force acting. But let's see horizontally. Horizontal force amount or the resultant force. You have a force 4 Newton to the right side and you have 8 Newtons to the left side. So here you can see I choose this direction as the positive direction. So this is getting the opposite direction. You are going to change the symbols. 4 Newton to this direction plus minus 8 Newtons to this direction, because when the direction changes it becomes negative. So minus 8 plus 4, answer minus 4 Newton to this direction. This minus sign is not a mathematical operation, that is about direction. So if it is negative to this side it should be positive. 4 Newton to the left side. So answer is 4 Newtons. Direction is not given here, therefore you are very easy to find this. You get the answer 4 Newtons. Now we enter question number 10. Balanced forces are acting on the moving object. If the balanced forces are acting on this, that means this object is moving at constant velocity. What happens to the direction of movement and the speed of the body? You can see this. The resultant force they are asking about this thing. Let's see how you find it. Direction of motion of the boat. Asking the resultant force in here. You can see this force is resistive force acting here, and this is the force propelled by the propeller in that motorboat. So if it is both are in this direction, we have a doubt now. What is the thing that causes this object to go forward? Both forces are acting to this direction, right? So remember one thing, you learn how we swim, called Newton's third law. If the propeller propels water with a 2000 newtons, there is a reaction exerted by water similar to that. That means every action has equal and opposite reaction. See, this boat is moving this way because of the push given by the water, because the propeller is propelling water backwards. So action is 2000 Newton to right side, reaction is 2000 Newton to left side. Now you can see there's a force of 2000 Newtons occur in this side. Resultant force we are going to find, or the unbalanced force you are going to find, plus this one. You can see 1800 newtons is the other force that is acting. It is acting to the opposite direction. So can we add these two? No, because these vectors are in different directions. So I will make this vector in the same direction like this, and now I am going to change this one as minus 1800 into this direction. Now you can see 2000 minus 1800, the answer is 200 newtons. Answer is first one.